The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. My name is Michael Meyer. I'm with Pacific Northwest National Laboratory. I will be presenting along with my colleague, Felipe Leon. We will be presenting on the Interior Lighting Campaign 2015 to 2019 results, which is also transitioning into the Integrated Lighting Campaign, and he'll be presenting more on that at the end of the presentation. As I said earlier, my name is Michael Meyer, and I'm with Pacific Northwest National Laboratory. This is a Department of Energy National Laboratory. I work in the area of energy efficiency. I've been with the National Lab for about 12 years, and I focus on market transformation of lighting products, as well as some regulatory and codes work as well. The first thing we'll talk about today relates to two upcoming events. It's always worth to promote those when we have an audience, so I figured we'd include those today. The first is the Department of Energy Building Technology Office 2020 Peer Review. This is an event that is in early May in the Washington, D.C. area. The idea here is that selected projects are presented. It's open to the public. It is free. You can come and learn about what we're doing, as well as provide us valuable feedback on where you think the project should be going, questions, or insights that you might have, saying, oh, we did that technology 2 years ago, and this is the challenge that we couldn't get around, or we'd like you to go in this direction. So as I've said, that is in early May in the Washington, D.C. area. You can find more information here, or you can just do a generic internet search for it. And if you're interested in becoming a reviewer or attending, there's all types of information. The second upcoming item is in early June. This is the Better Buildings 2020 Summit, also again in the Washington, D.C. area. This is a Better Buildings program is a program within the Department of Building Technology Office. It is groups like end users, sectors, and tries to get them to pool their knowledge base as well as their needs and try to focus on solutions that can help deliver value to that sector. So for instance, there's a multifamily housing, there's retail, there's healthcare, there's education. It pools those end users together, and they talk about some of the challenges they're having and source some of the products that they're trying to get, whether or not be energy management system or more efficient rooftop units, or in our case, better lighting. Also, there is a Better Buildings Challenge program, and the idea there is they work with you to try to improve your building portfolio or collection of buildings by about 20% of your energy to a certain benchmark. There's a lot more information. There's also good tours of buildings and projects within the local area, and that's again in early June in the Washington, D.C. area. So I just want to take the advantage to present those two upcoming projects. I should pause and say at this point that it is the webinar is being recorded. You are all in listen-only mode. If you have a need to communicate with us, there are two panes over on the side of your screen. One is the chat pane, in case you're having some type of logistical issue, which we hope doesn't happen. You can always type in there. The other pane is it's a little box. It's a question box. We will be receiving questions throughout the presentation, and then we'll try to attempt to answer them at the end of the presentation. So if you have a question, feel free to include it when available. And we do try to make our the presentations available at later dates. Just give them a little time to get posted in case you have to leave early or you have a colleague you'd like to share this information with. So we are here to present on the interior lighting, and then next we'll be presenting on the integrated lighting campaign. But it's first kind of a good idea to touch base on where we've come from. These are similar Department of Energy campaigns, past and present. So there's really three other ones that are worth noting. One is the Lighting, Energy Efficiency, and Parking campaign. This was started a number of years ago trying to promote energy efficient parking lighting, both in parking lots and parking structures. It completely is closed now because that technology is very mature and is very standardized, and many of the needs have been addressed with that area. There was the advanced Rtu campaign, which is in the closing down phase. Again, the idea there was a need for more efficient rooftop, which are air conditioning units that are mounted on top of the building. And so that campaign focused on how to make and how to get more efficient rooftop units installed on sites. Another one that is also in a somewhat of a closed down phase is the Smart Energy Analytics campaign. This is using building energy management and information systems to provide information and possibly fault diagnostics to make your building run and operate more efficiently. That is surprising that just by having better information about how your building is operating, you can use that and sometimes gain 5 to 10% more efficiency just through better operation. But those are all either campaigns that have existed before or in their closed down phase. But today's presentation will continue mostly on the interior lighting campaign. For those who may not be familiar with it, the interior lighting campaign started out first as a technical support and recognition campaign. The idea was started in 2015 that LED lighting is somewhat new. I know that sounds weird to say in 2020, but it was. There was many questions, whether it related to efficiency or light distribution or color metrics or warranty. While we were trying to get end users to transition to this newer technology, they were reticent, partially because of cost, but also because of unknowns. So there was limited technical assistance, maybe about how do retrofit kits work, why they would pick one technology over another, those type of things. Also through the course of the campaign, and you'll see some of this data there later, we did recognize the early adopters. And the idea of the recognition is the positive peer pressure, we always say. So what were your peers doing and why were they doing it, and what success did they get? That's what we try to get out of the positive peer pressure. The remainder of the presentation will be the results that we've gained from the interior lighting campaign, which ran from 2015 to 2019. So the first thing, so it's just kind of helpful to provide, we had two categories, those that are participants and those that are supporters. A participant is an end user, someone that operates or manages the building itself, someone who's essentially on the hook for the energy and the related cost of that energy. A supporter could be anything from a utility, possibly a manufacturer, an ESCO, anybody that's out there who's helping get good, efficient equipment and lighting systems to projects. You can see over at the beginning, we had a large interest and a large number of supporters and a large number of participants. These participants reflect those who joined each year. Some were very active year over year. And it's pretty common for there to be, as the technology matured, to be a reduction in participation. This slide separates that out by who the supporters were. You can see that we had a number of industry partners, either manufacturer or distributors. They were significant. They were the largest group of any type. But we also did have a number of energy efficiency organizations and program implementers and a few utilities who were participants. Each of these supporters plays a good role in helping advise on good projects out there, as well as their resources like utilities that we can point to and say, well, these utilities have incentives or other information. And so it's helpful to have a wide base of supporters if you are embarking on a similar type of campaign. This slide shows the lighting submissions year by year in category. So I've said before, there was two elements of this campaign. The first was support, and the second was recognition. So in the recognition campaign, these were projects that someone said, hey, this lighting project is really efficient. I think it's impressive, and I'd like to submit it to see if it's a recognized project. And that's what the whole recognition element was. We do say lighting systems because we did focus both on lighting equipment as well as lighting controls. We'll talk about the lighting controls significantly later in the presentation. You can see we did have a large number of different types of sectors, whether or not it was commercial real estate, healthcare, federal and municipal sites, as well as higher education. So each year we had a good number of different entities who sought out recognition because they felt they had a good project. Now, this is just the number of organizations that actually submitted for recognition. They are not the total number of participants. Also, it does not reflect the total number of projects that were submitted, just the number of organizations that participated. But here's the real meat. This is some of the numbers that I think are impressive and I think are worth seeing. Over the duration of the campaign, we had roughly 3.5 million lighting systems that were either retrofit or new construction as part of the participants. So someone joined and said, yes, I'd like to be part of your campaign, and here's some documentation and data on what we're doing, and we were actually able to catalog that information. As I said, it's about 3.5 million fixtures and lighting systems over, I think, about 2,500 buildings. And we have a good amount of information about how much wattage they were using, their operating hours, what they were using. You can also see that translates into significant energy savings. So those 3.5 million savings collectively save a little more than 800 million kilowatt hours every year, annually. That's just the 3.5 million systems. 800 million kilowatt hours, that sounds like a huge number, because it is. Easily to equate that, that's about $85 million in electricity savings through all these organizations and through their improved lighting equipment and lighting systems. This is by far some of the more interesting results and end goal that we saw. Each year we set the number slightly higher, and we are impressed that we were able to meet it, as well as some organizations helped us surpass it by themselves. They just had a ton of projects, and it was really impressive. But what we learned from that is more interesting. So we have, as I mentioned, 3.5 million fixtures and a number of installations. We found that roughly about 30%, 28% of all the lighting systems that we analyzed saved between 50 and 55% of the energy that they were compared to what they previously were. The vast majority of projects in those 3.5 million that I mentioned were retrofits. It was almost about a 90% to 10% ratio of retrofits to new construction. But that also makes sense. There's many more existing buildings than there is new construction. It's also easier to save energy by converting from fluorescent or HID technology to LED, so that also makes sense. We did see energy savings against new construction. We did treat that as a code baseline. You'll see we did also set a minimum efficiency requirement. We set it at about 85 lumens per watt for the fixture. Initially, that was a high number. It did, but the technology quickly caught up. Then we ultimately moved that bar to a minimum fixture efficiency of about 100 lumens per watt. It varied a little bit by its fixture type, but that was about the typical number that we used. We did need to set that as a floor, mainly so that way we could do some calculations. Also, we wanted to encourage a minimum use of efficiency. You can see that there were some projects, and small percentage, 5 to 10% of them, that were able to push the bounds of energy savings, pushing out to 65% energy savings, even 70, 75, and a few that broke that 75% threshold. Those few that broke the 75% threshold typically involved the use of high efficiency equipment as well as added on lighting controls. I think this graph is good to focus on for a second more, is that LEDs help you save energy. I think the simple takeaway is you can save a lot just by converting to LEDs and adding controls. I work on other projects, and I see project goals where I'll see someone say, oh, we're going to save 80 to 90% of our lighting energy. And when I see that, I reflect back on this graph and I think, whoa, slow down. You can see that as that percentage savings gets higher, there is a drop off. It is much harder, in my opinion, to go from 65 to 75 than it is to go from 55 to 65. So if you are embarking on an energy efficiency retrofit involving either equipment or lighting controls, I would just encourage you to moderate your expectations, and that you can probably get 55 reasonably, 65 with a little work, but every point above 70, is a lot more work than you think it is. It is a harder jump than the previous ones. So I just try to moderate expectations and not try to have people set themselves up for failure by saying, oh, well, 80% energy savings must be achievable because some project 2 years ago did it. It is possible, but it requires a fair amount of work and a lot of choices. Moving on, I think this is a good slide. This is some representation of a few of the projects that were recognized. We did see them across the board through different mechanisms. The Army, they were able to save about 63% on what we call a medium project and 72% on a large project. We'll talk about the project size in a second. Target has managed to replace most of their building stock and portfolio. They were able to save about 44% compared to new construction at some of their projects. They were also able to save on their retrofits as well. But I think it's important to see that it is possible to save against energy efficient codes as well through the right use of lighting controls and efficient equipment. Cleveland Clinic, they were able to save about 55% compared to the existing fluorescent. Cleveland Clinic opted to go more of the T-LED, which is a tubular retrofit lamp option, and kit option rather than new fixtures. I think that's an important thing to know, and that's why I included them in the slide, is that there is a limit to energy savings on the lamp, the T-LED retrofit option. We weren't able to suss out the data to that level on every project, but on some of the big ones we were able to see it, and there's some logic there where that your T-LED, it's fixed in form factor and some other reasons, so that's going to limit how much savings you can achieve. Your retrofit kit, you can save some more because of it's a broader surface area. You can push certain things out. You also can benefit from distribution and added on controls. So it's important to understand that when you're considering lighting savings from the equipment side, the equipment type matters. It's not just, oh, LED, therefore you can save a lot of energy. And this kind of also represents it. You'll see a pretty huge cluster right across the center section. This is the equipment savings. So this is what we saw when someone replaced their existing fluorescent or HID technology with an LED system. You can see the different colors represent different years, and that we artificially set up a criteria that we call the small project, about 25 fixtures or fewer on a project. A medium project was about 25 to 200, and then large was 200 and greater. You see, like I said, a big cluster in that 45 to 65% energy savings. This is just by replacing the equipment. But you can see that in some cases in 2018, we had one very large project that was over 1,000 fixtures that only saved 18% of the equipment. But equally in 2018, we had a large project that saved over 80% through the equipment savings. So again, just trying to go back to just because it's LED doesn't mean you're going to get significant savings, as shown by that less than 20% savings. But you do need to really kind of focus on what you're doing. Also, big projects can save a lot of energy, and small projects can save a lot of energy. I think people often feel that it has to be a large project to get significant savings, and we were able to see it on many projects of many size. This slide shows that data just reconfigured in a different format. Here again, you have the equipment savings, and when I say equipment savings, I mean this was analyzed for replacing fixture X with technology Y, and just that's before you layer in any controls. The different colors just show some different years, just to provide some perspective. This is just a side-by-side comparison of the different sectors. The dashed line shows the mean savings from the data that we analyzed. You'll see that they're all pretty much in that mid 50 to 60 range. The municipal is a little more, but there's really only 4 projects, so it's a little artificial, that value. Again, I think the takeaway here is that each of the different sectors can save significant amount of energy, as you see through there. But also, it's important to see there's a range of savings potential. It isn't all just a guaranteed significant number. And I think it's also important to see that just that sometimes projects cluster per savings. So that's kind of what they are. I do see some questions coming in. Thank you, and we'll address them at the end, but please keep them coming. I've mentioned, I keep saying it, and I'll mention it again, lighting controls. They're great. They help you get beyond just the equipment savings. I showed these two projects. They're from different years. One is at Northern Arizona University. They saved 46% compared to new construction. Part of that was through the use of significant energy lighting controls. Also, a General Service Administration, that's the federal landlord, they're able to save 77% in their retrofit. Again, the use of lighting controls helped them get there. Through the use of the data, or through the analysis of the data, we did discover some things about lighting controls, and I think it's worth touching on that in the next few slides. And again, I'm going to preface this, and I'll probably say it a few more times, I'm a big fan of lighting controls. Again, this is that similar slide that I showed earlier where we show the different sectors, whether it's commercial real estate, healthcare, or municipalities. In this case, the circles represent what the lighting control savings were compared to during the retrofit process, whereas the triangles are what if this was a new project with no lighting controls added in there. And you'll notice that the triangles are always higher than the circles. And the rationale is the reason is that when you do a retrofit process, more often than not, the savings you get from equipment dwarf some of the savings you get from the lighting controls. And as a result, the overall project saves a lot of energy, but it makes the percent savings from the lighting controls a little lower. And that can cause some challenges in that your cost effectiveness may be affected by your equipment savings save so much that it's hard to recoup some of those controls. Now, again, I've said it before and I'll say it again. I really like lighting controls and I support the use of them, but it is a challenge that we're seeing that by replacing equipment, which you should, you are somewhat, in some cases, hindering your cost effectiveness of some lighting controls. I only raise this as a caution to pay attention when you're going down that road. The next slide, again, kind of shows that similar example. I think there's two things to take away from this slide. So the first thing is just what is the slide? The x-axis is the portion of lighting fixtures utilizing controls on a project. The y-axis is the whole project energy savings as a result. So obviously, as more light fixtures on the project are using controls, ideally your whole savings are going up. But you'll notice to really get significant energy savings, you're really having to push to that 80% to 100% of all the fixtures on the projects utilizing lighting controls. And again, as I mentioned in the previous slides, the circle and the triangles, what happens in the circles is they first replace the equipment and then they added in the lighting controls, and that's why the savings appear a little smaller. The triangle is saying, well, what if this project already existed and we just added in the lighting controls? So you'll see that you always get a little more when you just consider that by just adding in the controls. But often we don't do that in the work. It's more efficient and cost effective to do it when you're doing the retrofit. So that's why we add in the controls at that time. The takeaway that I want you to get here is that controls are great. We do often hear savings. Someone will say, oh, well, controls save 30% when you do this. You have to think about that in the context. Is that 30% in just adding controls in where they didn't exist before? Or is that 30% in relation to part of the retrofit? And as I've said earlier, that retrofit is great, you need to do it, but it can sometimes minimize or reduce some of your savings from the controls because the equipment savings makes up a large portion. So again, it's just something to think about, but again, very pro controls, you should do that. This was some of the data we saw on the cost effectiveness of the project. These were just not all the projects we received, but they were the ones who were willing to give us a fair amount of data so we could do some analysis about the cost effectiveness. Table on the left, it's the different sectors, the energy savings you see, and then the third column is your simple payback year in years, and then the fourth one is the number of luminaires. We did that one just to get a perspective. Did it matter if it was a large project for cost effectiveness in case economies of scale played a role, or small projects, just to see how they related to each other. The graph on the right is the data plotted just so you can see it. So on the x-axis, you have energy savings, and on the y-axis, you have simple payback. The first thing is most of the projects had less than a 5-year payback, which is good. I work with a lot of end users, and they'll say stuff like, oh, I want a 3-year payback, or even a 2-year payback, and those can get really hard to achieve. Some of that is labor, and I think that's a great example, is the IoT sensor project on this slide. The federal government one that I'm showing that had a 57% savings and is the outlier at almost a 78% savings, that they were affected for two reasons. One, this was a historic building and they had more fixtures per square foot than normal because of the way the building was designed. And as a result, they just had more equipment. And so that drove up costs. The second was that because it was the building was occupied when they were doing the retrofit and a few other things, the cost of labor had to occur kind of on second shift and on weekends, and just had a high cost of labor. As a result, that drove up their installation costs, and as a result, that artificially inflated your simple payback. The other part of the reason why their payback may be a little affected was that it was a novel IoT, Internet of Things solution, and sometimes there's concern from the contractors on novel technology, as well as some hiccups in the field. So I think those all played a role in some of that. But I want to compare that to the retail IoT, which is the first one at the top. They're saving about 48% of the savings at this project, but yet their payback is 1.6 years. The reason is that as a retailer, they were able to figure out how to really focus on their building prototype and replicate this across many different of their buildings. As a result, that allowed them to really focus on getting the cost down. They were able to do the entire change out of the lighting installation, I think in 4 days, overnight while the store was closed, and they could do it through a series of journeymen and electricians, so they were able to really minimize the labor costs related to that solution. So the key takeaway here is it is possible to get significant energy savings, such as 74%, and still a pretty reasonable payback of less than 3 years. However, like all things, there are caveats, and depending on your sector or some of the options you choose, your payback might exceed that, and as shown by a few of these different other projects in this slide. So again, lighting retrofits are pretty reasonable. You can save a fair amount of energy and make them cost effective. You just have to do it carefully. Summary, before I move into kind of some novel things we also saw, we saved about 3.5 million luminaires were documented for saving about 800 million kilowatt hours and $84 million as a result. There are 10 published case studies on the interiorlightingcampaign.org website if you're interested in learning more about them. And as I mentioned, I showed you some of the results. There were about 51 exemplary projects demonstrated. The next few slides were, in the final year, we moved beyond just lighting and really tried to say, well, what else are you doing with lighting? What novel things you can do? So this is a government facility, which is, again, the General Services Administration, and they received exemplary sector recognition. They had used integral daylight and occupancy sensors in this LED retrofit kit, but they were also able to use Internet of Things, and they were able to do presence detection, and that was actually informing the air conditioning HVAC system. So they were doing setbacks when spaces were not occupied. And the presence detection also was aiding with space utilization, which is shown in the upper right graph to get a sense of, well, what parts of this office are being used or not used, which helps with space utilization and those real estate. The next slide, in my opinion, really shows, when we talk space utilization, I think the static heat map is hard to understand. So what you're seeing in this graph is up in the right, you can see the time. It's now 7 a.m. And the blue dots are showing the presence detection, essentially response. The bigger the circle, the more presence is being detected. And so you can see through the course of the day just what parts of the building are getting more use of space, or not more use of space, but more people are working in that open area of this floor. This is space utilization. This is helpful if you were doing resource loading. You could, if you had either an educational building or possibly a healthcare building, you could possibly push people to one part of the floor or redevelop something. You're saying, wow, no one's ever using this conference room. We can use that type of space. We did calculate this for just one day, but we also were able to do it for all the days of the week through the course of the year, is what you're seeing in the aggregate. The bottom graph is just kind of showing you all the days kind of simultaneously. And this office has a flexible work policy on Friday, which is why you have a low use of space on Fridays. As a result, they were able to negotiate. Well, they're still working on it, but they're now analyzing how they could manage either maybe the janitorial costs or maybe the HVAC system of actually really reducing it on Fridays when they know the space has low to no occupancy by pushing people to different parts of the building, but so really pushing the savings. So this is some of the stuff that we saw towards the end of the project, the interior lighting campaign of what people are doing with integrated sensors and really trying to get more value than just lighting energy savings, which I think is the next step that we need to do. The other thing that we saw through this, so this is now orange, and what you're seeing, this is the daylight response. And what you're seeing in the upper right-hand corner is the time of day, and the building is orientated. The north is at the top, south is at the bottom, east is on the right, and west is on the left. And so as you would think that the sun rises on the right, it's going to go down to the bottom of the screen, and it's going to go to the left. So these orange sensors should be getting bigger as the sun is moving, which is what you're seeing kind of on the right and bottom and moving to the left. But you'll notice as I've been speaking during the slide has been running, certain sensors, there's one in the top kind of center that essentially seems to be firing all the time. Again, these are daylight sensors. They should be firing, the larger they fire, the more they're responding to the daylight. This shows for commissioning reasons, when we have a lot of sensors, we need better tools to analyze how effective our daylight commissioning is. So while daylighting controls can save it, it can sometimes be thwarted at the commissioning level. And through better analytics, we're starting to see that. And the next step is really getting it to more automated to flag us what are some of the potentials and issues related to the way this fixture was commissioned. I'm now turning the remainder of the presentation over before we get to questions to my colleague Felipe, who will discuss the integrated lighting campaign.
Thank you, Michael. I appreciate that, and I appreciate your presentation. And I'm Felipe Leon. I'm with Pacific Northwest National Laboratory also, and I've been with the lab for about 5.5 years now. And I've been with the interior lighting campaign since it launched back around 2014, 2015. So it's been really great to see that when the campaign started, we were at 0.1% adoption in troffers as it relates to high efficiency troffers, and the campaign evolved to include both high bay lighting and linear suspended luminaires. But now we're excited about the next evolution of the interior lighting campaign towards this integrated lighting campaign. And the reason is that, as you've shown on your slide, when we get this kind of information about occupancy, about daylight, we're looking at deeper energy savings, because now we can use that sensor data for other systems. So there's definitely an energy story there to be had, but we know that there's also the value that non-energy benefits can afford in helping drive the adoption of high efficiency lighting and controls. But sometimes it's a bit of a mystery these days to see that there's potential in HVAC, there's potential in plug loads, there's potential in using these sensors for other reasons. For example, to understand the occupancy of spaces, so you can optimize your space needs. How much does that really save a business? So that's something that the integrated lighting campaign will be focusing on. And we're back at the beginning of what we had in the interior lighting campaign. In those early days, lighting, LED lighting, high efficiency lighting was very new, and people had a lot of questions. Now we're looking at these systems and how they interact with other building systems and how they drive value to a business through information about the way they operate and how much they're able to save or gain from that information. So that's something that we'll be focused on going forward. Next slide. So before going on to what the integrated lighting campaign is about, I'd like just to start with definitions, because there's a lot of new things. We talk about connected lighting, we talk about in the integration of these systems. So I just want to set the stage for what the integrated lighting campaign is going to focus on, even though it's not going to be just looking at one single thing. But if we think about the word integrated and what that means, it means a situation in which many different parts are closely connected and work successfully together. That really is what we're looking at, is going beyond lighting here, with lighting being the use of electric lights in a space or place. Now the campaign, the interior lighting campaign was a series of planned activities that were intended to achieve a particular aim, and we had many different ways in which we did that. We talked about recognition. We also provided resources, and we also provided some technical assistance to people so that we could help them understand their options and know to ask the right questions. So our definition here, what does the integrated lighting campaign mean? What are we going to do? It's going to be a series of planned activities aiming to demonstrate the benefits of lighting and other building systems that are connected and working successfully to enable deeper energy savings and other benefits. The other benefits here being, of course, an important aspect of it. Again, this is going to be the primary focus of the campaign, but there's a lot of excitement. There's a lot of new things going on in the world of lighting. You know, for example, there's advanced sensors that might be able to get us beyond just your typical occupancy and daylight sensor. So we definitely want to keep an eye on that, and we'll probably incorporate that into the campaign. This, of course, these new sensors can help deepen energy savings and provide significant value to building owners. Next slide, please. So why integrate lighting? We know that there's an energy saving story here. We know that lighting, when you use these occupancy sensors, the daylight sensors, you can dim the lighting, you can turn off the lighting depending on, you know, what the environment is in your space. Is somebody in that room? Do you really need to be lighting that space? But beyond that, do we need to be heating or cooling that space, right? So there's an HVAC component here. You've got a sensor, it's already in the lighting, it's already able to communicate possibly to that building. When it's integrated, then the HVAC can take advantage of that knowledge and then adjust the setback temperature for that room, or turn off the ventilation to that room depending on the occupancy. Of course, you have also the opportunity for plug loads. There's many different things that you might have plugged into a wall, maybe a space heater, maybe a printer, where if there's no occupancy, if there's no activity in that space for a significant amount of time, you might be able to turn things off, uncontrolled plug loads, where you can actually turn things off, lamps, for example. And again, as Michael mentioned, as the energy use of lighting has gone down, the story for the lighting controls and the ROI has been decreasing. So that's something that, by looking at these other systems and being able to quantify these HVACs, we can once again say, hey, not only will you save a little bit on lighting, even though it's diminishing, now you can save on these other building systems. You can save on HVAC, and you can save on plug loads, and that might make the story again for these occupancy sensors to have value again, added value. But beyond the energy story, there's that other benefit story. It's the asset tracking potential. It's the business intelligence, and it's the customer engagement that you can have. The sensors that we're using in lighting today are just a start, where you can start having situations where not just occupancy, but the number of people in a room might be information that you have at hand. That's valuable. Where you have acoustic sensors or sound sensors that can tell you something about an activity in a space, or it can tell you about the security in a space, where you might have gunshot detection that can help you understand when there's an emergency. Or where you can have interior GPS or positioning to allow you to have that customer engagement, as you'll see in one of the cases here. Those are all new things that the world of IoT is bringing. Internet of Things is essentially a sensor that provides you some capability to understand what's going on in your building. So that's why we're looking at lighting as a platform, and I'll explain here in a second, but it's basically going to be a network of sensors that can help make a building smart. Next slide, please. And I'm sorry, we're going to go to a poll here. So as you think about this question that's coming up, please please share your thoughts, whether you're in organization that is a building owner. Have you installed, or are you considering installing a lighting system that's either connected or integrated? If you're a manufacturer, let us know if you've developed these kind of products or are considering it or not considering it at the moment. If you're a utility, if you're incentivizing, please select one of these options. And we'll just take a few seconds to give you a chance to read through these. If you are not one of the ones that I just mentioned, utility manufacturer, vendor, or building owner, please choose the one that's closest or that you most closely relate to. For example, energy efficiency organizations, maybe that you provide an incentive, or you may be already seeing projects that you've installed with some of your buildings. So we'll just take a few seconds to help us understand what the state is of adoption or development on these integrated systems. Great. And I believe that since we are back, that many of you were very efficient in answering the question, so I appreciate your input. And if we can move on to the next slide. So we talked about why integrate lighting, but then you might say, well, why lighting? Why do I have to do it? Why can't I just have a standalone solution? Why can't I just put my sensor on the ceiling or on the wall, right? So the thing about lighting that's, I'm going to say pretty unique for any of the systems that we have in buildings is that it's all around us. And beyond that, it's an eye in the sky. It's ideally located where it can actually see pretty much everything within a space. If you're on a wall, you might have things that are obstructing your direct line of sight. If you're on the floor like a wall outlet, you may not have visibility, especially if you're, for example, underneath a desk. The other thing about it too is that lighting requires a power source, so you already have power going to that to that luminaire, so we can leverage that. We can actually say I can actually plug in something else, and the power is already available at that location. But also, it may already be providing some useful information if it's transferred to a building system, a central location. You've got occupancy and daylight sensing, and Michael showed that. So where you can already capture the data from sensors that already exist and start leveraging that, that's just a start. So that is why we think lighting is uniquely positioned to be that platform that can be useful in a building to help you install new sensors and new capabilities. Next slide, please. So the question becomes, is it just hype? We know that in the early days of LED lighting, there was a lot of hype around how long things will last or how much energy you will save. Some claims could be optimistic, but the truth is that there are some building owners that are already starting to adopt this, and they're starting to realize benefits. Target, for example, has installed lighting that allows you to do some positioning, and this is built in with their app. So this can drive revenues, and when we start thinking about the impact to revenues, we start thinking of a completely different value proposition than just energy savings alone. So how much is Target able to get out of this new capability that helps their customers better navigate their store and find what they need? The heat mapping that Michael showed can provide insight about your space utilization, allowing you to optimize how you're using your spaces throughout a week, or how you're heating or cooling your spaces based on the needs. And then there's been a lot of research too. Lawrence Berkeley National Lab has demonstrated the value of an integrated system approach and a significant amount of energy savings that you can get. And this, of course, covers several measures. We see that 83.7%. I'm certainly not trying to drive the hype here. That is a significant amount of integrated system approaches that were done, both through research as well as through modeling. And that included occupancy and workstation specific lighting, daylight, dimming and lighting controls, and plug load controls are some of the packages that they've delivered that allow utilities to look at these packages and develop incentives around that. And that is part of their Beyond Widgets research. So that's certainly something worth looking at, especially for those utility participants in this webinar. Next slide, please. So lastly, these systems are new, and as with any new technologies, they are going to have a cost component. They are going to be expensive. And you might ask the question, can I afford it? What I might say is, can I afford not to? And certainly I can say that I've worked in a company where it innovation may have lacked, and it may have led to that being an impact to its business. But some might ask, can I afford not to? That's certainly what I have on the quote up here. Innovation is fostered by information gathered from new connections. That's what we're trying to do here. We're trying to get the insights gained looking at these networks. That innovation is going to rise from an ongoing circle of exchange where information is not just accumulated or stored. We want to use that information to help drive business value and to help get that deeper energy savings. And that's going to be generated from these new connections that we're creating here with lighting. The connection between lighting, between plug loads, between HVAC, and between the business systems that can use that information to gain these benefits. And also, for those of you that might be thinking that it's expensive, take a look at your utilities. Take a look at the incentive programs that they're developing. Many of them are already actively incentivizing or considering incentivizing some of these systems. Certainly for the energy story, they're developing both prescriptive as well as custom incentive programs where the customer looking at actual measurement of the energy savings, and they're able to incentivize based on how much energy savings you're getting from this. So you expand beyond lighting energy savings, and you're able to get those HVAC and those plug load energy benefits that will show up on your bill, and that will show up as an incentive. And certainly there are some prescriptive programs also where if you bought a certain system or a certain luminaire, you'll be able to gain those benefits. So I like to set the stage for the next poll question, which is going to be what your interest level is. We know that there's an energy story. We know that there's an other benefit story. On this next poll question, please go ahead and select 2 options from what is presented to you of what you would see as a value to your business. What are you most interested in use cases related to lighting? And we'll take just a few seconds to allow information to come in. Great, thank you very much for your input. So let's move on to the next slide. And I'll just talk about what the integrated lighting campaign will do here. Again, this is modeled after the interior lighting campaign. Although the website will look a little bit different, it still is going to serve as a resource of information for those looking at these new integrated lighting systems. It's going to encourage and recognize successful integration projects. We certainly want to know what some of the people that are doing this are gaining from this, and then build that body of knowledge. As Michael mentioned, we had a couple of case studies that were developed from those that we recognized in the interior lighting campaign. We'll be doing the same here. We'll be building that body of knowledge through these case studies, through showcasing some of the benefits, and of course through recognizing those that are having exemplary projects. And we'll also provide technical assistance as you have questions about an integrated system where you're now able to connect to HVAC and plug loads. What are some of the things that you want to be on the lookout for in order to select the correct system? So that's something where we can help with some limited technical assistance. Next slide, please. So how do I get in on this? That's a question that we might get. The interior lighting campaign was open to anyone that supported, of course, our mission and all building owners that were looking to upgrade their projects to high efficiency lighting. Participants, of course, as Michael mentioned, are the building owners or the building managers that are actually installing these systems. While supporters are utilities, energy efficiency organizations, manufacturers, design teams. At this stage, we haven't formally launched. I'll talk about when we're going to do that, but we are interested in hearing your perspectives. We are interested in hearing about your projects, and you can send an email to integratedlighting@pnnl.gov. But if you're looking at if you have a completed project, if you're considering one of these integrated lighting systems, if you develop products that allow for this integration of lighting with other building systems, if you're incentivizing, or if you're considering incentivizing these kind of products, if you're a utility, please get a hold of us and let us know what you're doing so that we can start capturing this information. And again, if you need technical assistance, it's also not too early to start reaching out to us and getting some assistance in selecting these products. Next slide. So when will this happen? We have a formal launch event, which will be at that 2020 Better Building Summit that Michael mentioned. That's going to happen on June 8th to 10th, and that'll be a formal announcement where we'll also have a session where you will be able to share your thoughts and experiences. So if you happen to be at the 2020 Better Building Summit, please look for the Integrated Lighting Campaign launch event, and I hope to see some of those on this call visit us at that event. Next slide. And the next slide will just be a thank you for listening. And again, if you have an interest or if you have any thoughts on the Integrated Lighting Campaign and our work, please feel free to send an email. We look forward to hearing about all the great projects, the great integration that's going on with between building systems. And at this point, I'll kick it back to Michael for some questions that we may have received.
Thanks, Felipe. Yeah, I have questions coming in on one screen, so I'm parsing them. I'll give you a second to just rest your voice, and I'll then kick a couple questions over to you. I think there are first two back to the interior lighting campaign that they're related, so they're worth addressing. So I'll answer them. The first one was, why were some savings so low? There's a couple of reasons. I mean, first, that most of those data points are represented by a few projects, not any one single project. In some cases, some of the fluorescent systems were very efficient. And then added into that, they were possibly earlier, and so the efficiency of the LED system wasn't as significant as it is today. So, I mean, to put this in perspective, we have at the start of the campaign in 2015, 2016, typical fluorescent fixture again, efficacy could have been anywhere in the neighborhood of 55 to 65, maybe even 70 lumens per watt. That's at the fixture level. At the time, in again 2015, 2016, the LED fixtures, some of them were just around 85 lumens per watt. So if you start just comparing the efficiency of the two devices, going from a fluorescent device that's 65 lumens per watt to an 85 lumen per watt LED device, that's where some of that low savings came from. There were a few others, but more often than not, it would have been kind of an older, less efficient LED technology. Now, efficacy is not the only thing to think about anytime you're looking at a project. There's definitely sometimes a color quality trade-off with efficacy, and glare. Glare is a huge color trade-off with efficacy. So I don't want people to zone in on a number and say, well, all LED equipment should be 100 to 120 lumens per watt. Often the more visually pleasing and low glare products are going to have a lower efficacy. So for instance, if you have an LED device that may be 120 lumens per watt now, a lower glare version of it might only be 105 lumens per watt. So you are going to take a small penalty in terms of efficiency for glare and some color metrics. As a result, therefore, some of those projects that I mentioned, they may have been opting for really high color quality metrics and or visual appearance, and as a result, that's why it's a lower efficacy of the LED fixture, and that may have affected some of their savings. Equally along those questions, what is the reason for the outlier at 70–75% graph on the savings? I think there's two questions in here, and so I'll try to see if I can address them. One, where did the 70–75% savings come from? More often than not, it related to, it was equipment change. In some cases, we had 4-lamp fluorescent fixtures that were just monsters, and when we replaced them to the LED, there was an efficiency gain, so that's how we got to 75%. Sometimes it was a lens fluorescent fixture, which is pretty inefficient. And when you converge to the LED, you got a lot of savings as a result of it. So that's one reason for the outlier. I would say some of the other outliers we saw were that because I think this goes back to more the histogram question, or I hope it goes back to the histogram question of why were some of the LED fixtures more efficient, so why were some projects more efficient, and why we had essentially a larger spike at 70%, 75% versus the other histogram. And the answer there is, I would say, it's a recognition program. So some of the projects we saw might have been standouts, and so we saw those projects that really went beyond the typical savings versus just a huge analysis of every project submitted to a utility per se. So because it was a recognition, we do have a little bit of a bias where some of these projects were already good, or some of them were really good to begin with, and that's where I think some of that outline came from. I hope I answered those two well. I'm going to take a pause for a second. I'm going to turn over 1 to 2 of the questions to you, Felipe, and then if there's time, we'll keep on going. One question is just a straight question of, if we registered for the interior lighting campaign in 2019, do they need to renew it for the integrated lighting campaign, or is it an auto renewal?
That's a good question, Michael. We actually have outreach efforts going on right now to all of those participant supporters from the interior lighting campaign. We are, of course, trying to make sure that you are interested in continuing to the integrated lighting campaign. It is still open to you. But we are doing outreach to not have it just be an opt-out, but rather an opt-in. So as you get emails from us, please just respond, and we're just asking for a real quick either email response or a conversation to make sure that we are on board. But that's also providing us some information about your integrated lighting projects or your thoughts about some of these projects. So it'll be really great to once again touch base with all of our participants and supporters and make sure that you're still interested in the integrated lighting campaign.
Okay, the next one's kind of twofold. I'll quickly answer the first one, and then I'll push the second one to you. One question is, they're both related to data. One is about the poll results, and the simple answer there is we will probably release these poll results in some form, whether or not it is a part of this webinar recording and we publish them there, or we use them in our other material saying we asked a question and this was the type of polling results. We do try to release as much information and disseminate it as best we can always. But this is actually a larger question. A person asked, who owns the data related to the case study as well as related to the integrated lighting campaign? And I think that should go both ways, both the case studies, but also just related to any of that data that's generated through integration.
Okay. So I think there might be 2 aspects to that question. Who owns the data? If it's related to the interior and the integrated lighting campaign, I think that's really a lab resource, a DOE resource, our organizers. We're just recollecting some very basic data. But as it relates to these integrated systems and the data they provide a business, I do not get in trouble with any lawyers out there. I'm going to say it depends. Many different manufacturers are providing this capability and are also providing a service where they're handling data for clients, for their customers, in some kind of lighting as a service or some kind of system as a service, where they may have access to that data. Other building owners might be a little bit more wanting to control that data and make sure that they get either are the only ones that are able to access that data, or that they're sharing in that data. So it depends on what kind of agreements you make with those that install and those that deliver these systems. So it really depends. Those are legal contracts, and it would be really hard for me to say who owns the data without really knowing what the contracts or the agreements are between those two organizations, the provider as well as the recipient of the technology.
Great. I am always conscious of time, and I'm beginning to see a few people drop off the list. We did block this for an hour, so there's a number of comments or questions that will follow up separately related to this. Since you've submitted them, we see them and we can respond to them directly that way. I want to say thank you. You have the email address for the integrated lighting campaign. This will be made available at some point in the near future. Thank you for your time today, and we'll continue to follow up with additional outreach and answer questions. Thank you.